Then we have the paper on reviewing key issues of operational risk credit modeling. And so there's the discussion here of the actuarial approach, specifically loss distribution approach, or LDA as an actuarial approach, which is in the FRM going to be the most common approach to operational risk. And at the heart of it here is the identification of operational loss cells. And oftentimes that's because the bank also needs to meet regulatory requirements, and the Basel framework dictates the use of a business line event type matrix. And so we have operational loss cells. And the essential feature here of the LDA is this idea that we take the frequency, that we can characterize the frequency of operational losses and compound or convolute that with the severity of the operational loss conditional on them occurring. So if you think about any sort of generic operational losses, they occur with some frequency, and then having conditional on their occurrence, they have some severity. And of course, the frequency will be a discrete distribution, almost always, a counting distribution, and the severity distribution will tend to be a continuous distribution. And so then another common dilemma that we see thematic with operational risk is a difficulty of having lots of relevant data in the loss tail, and the need to complement any internal data with some, or supplement with other data sources, including consortium, commercial, and external. So compounding or convoluting or tabulating these two together into gross losses, deducting for the benefits of any insurance, net lossing, gives the firm an aggregate. Also, the key idea to include correlations or dependencies. Probably would be better to say dependencies there. And then an overall aggregate distribution for the economic capital. And so those cells, a key aspect there is we have business lines and then event types, and then Basel has 7 event types, 1, 2, 3, 4, 5, 6, 7, and typically then the bank will not necessarily want to use all 7, but they may define an internal event type as fraud and map that to both internal and external fraud for the Basel. So in this example, from a case study here, Deutsche Bank had 5 internal event types, but all 7 of the Basel event types were covered because fraud was mapped to internal plus external. Infrastructure was mapped to 2 of the event types as well. So you can see this is just a business line event type, just a matrix that sort of in 2 dimensions characterizes the organization and where the event losses can occur, where the operational losses can occur, because we don't expect operational losses to all exhibit the same kind of. We want to characterize these as random variables, and they're not all going to be the same depending on the event type, and they're not all going to be the same depending on the business line. And so this paper is largely about all of the issues associated with our attempt to characterize operational risk, including the difficulty with internal data and how to classify it. Okay, another classic problem. This is always an issue in finance, but this again manifesting now in operational risk. The length of the internal data sample. Frequency in internal loss data. The problem is that it is entirely possible that there's either no loss event at all in the internal data set for some units of measure, or the frequency appears abnormally low. So this is our thematic problem. But that matrix helps us. You will recall. Give us an internal map to the organization, but fully realize there's 8 times 7 or 56 cells there. And so among 56 cells for the one organization, it's always going to be the case that some of those cells are going to be empty. They're going to have zeros in them. And so, but the zero going forward is not going to be useful to us. We have an issue with severity of the internal loss data. Delays in reporting. Protracted or split events. Mergers and acquisitions. Then we have, so all of these internal data issues probably necessitate complementing or supplementing the internal data with external data. And then, of course, the external data we have data issues with that. Relevance of the external data points. Quality of the external data points. Nature of the information in the external database. I think that's related to quality. Biases, including reporting biases. And scale bias. So there's a discussion about how the frequency and severity distributions are obtained. In terms of the frequency, remember that's a discrete or counting distribution. So the most commonly considered binomial Poisson negative binomial. The Poisson seems to be the one in the FRM that we've most commonly encountered, the Poisson distribution. Very simple, that one lambda parameter. However, there's the caveat that this the frequency distribution is not nearly as consequential as the severity distribution. There are two key problems in using a single severity distribution over the entire range of severity. One, it is unlikely that the internal and external loss data are drawn from the same severity distribution. And there's a general recognition that a single parametric distribution is inadequate to capture the probabilistic behavior of severity over its range. And so a natural solution to the challenge of using a single distribution for severity is a piecewise approach. And so here that's where we have maybe we use empirical data to characterize the body, and we graft on a parametric distribution to characterize the tail. And so, in the case study, in some of the, it's been a thematic in the FRM, not necessarily with the current readings, because there's been a lot of churn in the operational risk. But extreme value theories come to the rescue to characterize that tail for operational risk losses where we don't have the data. And in practice, the selection of the severity distribution is more art than science.